Let us start CBSE class 10th mathematics chapter 7 coordinate geometry. You see, first of all, going to exercise, let us understand some formulas. The distance between the 2 points, let A and B are the 2 points and its coordinates are x1 y1 x2 y2. So the distance between A and B will be worked out. From A, you drop a perpendicular AL on the x-axis, and from B, drop a perpendicular BM, and from A again you drop the perpendicular to BM, that is AN. So the distance between AN will be x2 minus x1, and the distance between B and N means that will be equal to y2 minus y1. So applying the Pythagoras theorem here, the perpendicular square plus base square will be equal to hypotenuse square. So that AB will be equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. This will be the standard formula to find out the distance between the 2 points when the coordinates of those points are given. Now proceed to the coordinate of the points of division, or the section formula you can say. So this section formula is divided in 2 parts, that is internally and externally. Let us proceed for internally one first. Let P and Q are the 2 points whose coordinates are given, that is x1 y1, P is x1 y1, Q is x2 y2, and there is a point R which divides the line segment PQ in the ratio of M1 and M2. We have to find the coordinate of the point R, that is xy. So there are, you see, just drop a perpendicular from P, that is PM, from Q to the x-axis, that is Qn, and from R, that is RL. So these are the perpendicular distance on y-axis from P, Q and R. So from P, again you drop a perpendicular to RL, that is PK. From R, you drop a perpendicular to Q, QN, that is RS. Now let us find the distance between PK. That will be equal to C. OL is X and OM is X1. So X minus X1 will be the distance between PK. Similarly, the distance between R and S will be equal to X2 minus X1. You see, ON is equal to X2 and OL is equal to X. So RS is equal to X2 minus X. This R divides the line segment PQ in the ratio of M1 to M2. Now find out the QS first. That is, you see, this is the perpendicular distance. So y2 minus y and RK is equal to y minus y1. There are 2 similar triangles, you see, PKR and RSQ. These are the 2 similar triangles because these angles are equal, corresponding angles are equal. This is 90 degree. Angle K is equal to angle S, that is 90 degree. And this angle is corresponding angle, means angle P is equal to angle R, that is corresponding angle. So the two angle criteria of similarity, these 2 triangles are similar. Therefore, the similar triangles, their corresponding sides are proportional. So in similar triangle PKR and RSQ, you see the PR upon RQ is equal to Pk upon Rs is equal to Rk upon Qs. So as you know that PR by RQ, here you see PR that is M1 and RQ that is M2. Here Pk that is x minus x1 upon Rs is equal to x2 minus x. Similarly for Rk that is y minus y1 and Qs is equal to y2 minus y. So we have to find the coordinate of the point R, that is x and y. So let us solve it. First of all, you take these two relations, first and second. From there you can work out x is equal to m1 x2 plus m2 x1 upon m1 plus m2. Similarly, if you take first and the third one, relation of proportionality, you will get y, the value of y you will get, that is m1 into y2 plus m2 into y1 upon m1 plus m2. Here the R divides internally the line segment PQ internally. Now proceed for the externally. When the point R divides the given line segment externally, at that time the point R will be not in between the P and Q, it will be outside of PQ. So in similar triangle here you see this P and Q are the line segment. This PQ has been extended to the point R. The distance, the ratio from P to R is M1 and Q to R is M2. Again here also, if you just drop a perpendicular PM, QN and RL are the perpendicular to the on x-axis. Again you drop a parallel line, you can say, or you just drop a perpendicular from Q to RL, from P to RL. Now in similar triangle PKR and QSR, you see the corresponding sides are proportional, so PR upon QR is equal to PK upon QS is equal to RK upon RS. Here you see the PR that is M1 and QR that is M2. Again PK, you see PK that is x minus x1 and QS, you see QS that is x minus x2. Now taking the relation between first and second of proportionality, you will find the value of x, that is the coordinate of the point R, abscissa point. So m1 x2 minus m2 x1 whole divided by m1 minus m2. For y ordinate only, you can say that is m1 y2 minus m2 y1 upon m1 minus m2. Now this section formula will assist you to understand the point of centroid, which is known as where the median intersect each other. This is the centroid of a triangle. Here ABC is a triangle and AD is the median, means D divides BC in two equal parts, that is the D is the midpoint of BC. There is a point G from where all the three medians passes, and that point is known as centroid. So this centroid divides the median in 2:1 ratio. So in order to find out the coordinate of the point D, that is the midpoint of B and C, is just x1 plus x2 divided by 2, y2 plus y3 divided by 2. This will be the midpoint of here. Now we have to find the coordinate of the centroid, that is HK. Here I have taken HK is the coordinate of centroid. So H is equal to x1 plus x2 plus x3 upon 3, and K is equal to y1 plus y2 plus y3 upon 3. You see the x1, y1, x2, y2, x3, y3 are the coordinates of the point A, B, C respectively. Now proceed to how to find the area of the triangle. You see the triangle ABC. Here the triangle ABC is given here. From the point B, A and C drop perpendicular, that is BM, AL and CN. And the coordinate of the point A is x1, y1, B is x2, y2 and C is x3, y3. So area of the triangle will be equal to the area of the trapezium ABML. ABML plus the area of the area of the trapezium ALNC. ALNC means we have to sum up the area of the two trapezium and subtract the minus the area of trapezium BMNC. BMNC. So in order to find the area, first of all we have to add the area of the trapezium ABML plus area of trapezium ALNC minus area of trapezium BMNC. Now proceed. From here you see area of trapezium is, general formula you can tell you the area of the trapezium is sum of the parallel side into perpendicular height between the parallel side. So here you see x1, y2. x1, y2 plus x2, y2, x2, y3 plus x3, y1 minus x2, y1 plus x3, y2 plus x1, y3. So you see here x1, y1, I have written the vertices, coordinate of the vertices of the triangle. So x1, y1, x2, y2, x3, y3, again x1, y1. So the complete dark line, first of all we just proceed from this, that is x1, y2, x2, y3, x3, y1, and after that there is a dotted line. So in the dotted line, before that you have to put a minus. In order to remember, just I am telling you. So for the area of ABC triangle will be equal to 1 by 2. You see 1 by 2 x1 into y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2, bracket closed, and outside there is 1 by 2. Again the determinant formula, you can say x1 y1, x2 y2, x3 y3. Put 1 1 here. So it is the determinant of 3 into 3 order. 1 by 2 before that. So area of the triangle will be equal to, you can just remember like this, 1 by 2 sigma means summation of x1 y2 plus x2 y1. Note the area is always positive. In case getting negative, then ignore the negative sign. If A, that is x1, y1, B, x2, y2 and C, x3, y3 are collinear points, that is the lies on a straight line, then the area of the triangle is 0. Means if you have to prove that the three points lies on a straight lines, the area of the triangle will be equal to 0. In case if you have to find out the area of the quadrilateral whose vertices are given, you see here the vertices are given, that is A x1 y1, B x2 y2, C x3 y3 and D x4 y4 is given here. You just write it in the form of given as below. You see x1 y1, x2 y2, x3 y3, x4 y4 and again you write down x1 y1. So you see 1 by 2 x1 into y2, x1 into y2 plus x2 into y3, x2 into y3 plus x3 into y4, x3 into y4 plus x4 into y1. Here I have written x4 into y1. The bracket closed. In the second bracket, before that you just put a minus sign and proceed. You see x2 y1, x2 y1 plus x3 y2, x3 y2, x4 y3, x4 y3 plus x1 y1, x1 y4. So before that you put 1 by 2. So this will be the formula for quadrilateral. Straight away you can find out without adding the area of the two triangles. Now the area of the equation of line or straight lines. Here you see the equation of the x-axis. Equation of x-axis is y is equal to 0. Equation of y-axis is x is equal to 0. The equation of line parallel to the coordinate axis that can be given here, you see the parallel to x-axis, that is y is equal to plus minus a. If it is plus, then the line will be above x-axis, and if it is minus, then the line will be below x-axis. Parallel to y-axis, that is x is equal to plus minus b, means when it is plus, suppose the parallel line to y-axis, that is x is equal to plus 5 or plus 7 or anything, then it will be the line passing from the right hand side of the y-axis. Right hand side of the y-axis. In case it is negative, the line will be parallel, but it will be on the left hand side of the y-axis. Now equation of the line in the form of gradient. You see there is a line AB which makes angle theta with the x-axis in the positive direction and cuts an intercept on y-axis, that is C. C is the intercept on y-axis on the line AB, and it makes angle theta with the x-axis in the positive direction. So here if we draw a line parallel to x-axis, CN is the line parallel to x-axis, then again this angle will be theta, and this is also theta, because the corresponding angles. This is 90 degrees, this is again 90 degree. So these two triangles are also similar. Now you find out, first of all, you see Pn, that is y minus c. You see this is c. So from P to M, that is y. P to M, that is y, and OM, that is x. Here I have written x, here I have written y minus c. So y minus c by x means perpendicular divided by base, that is tangent theta, that is slope of the or the gradient of the line AB. So y minus c upon x is equal to tangent theta, that is equal to m. So y minus c is equal to mx. Y is equal to mx plus c. The gradient is equal to the tangent theta or m. If the line passing through the origin, then c will be equal to 0, means the intercept on y-axis will be 0 because the line is passing through the origin. And the equation will become y is equal to mx. Now the equation of the line in the intercept form. Area of the triangle OAB, you see, there is a line AB which cuts an intercept on x-axis, that is A, and the intercept on y-axis is B. So the coordinate of the point A is A0, coordinate of the point B is 0B. We have taken a point P xy and now drop a perpendicular to x-axis. So OL is equal to x and PL is equal to y. Now the area of the triangle OAB, the bigger triangle, that will be equal to, just you have learned the formula, 1 by 2, 0 into 0 minus b plus a in bracket b minus 0 plus 0 into 0 minus 0. Because the coordinate of the vertices are given, this is the origin, so 0, 0. Here A0, here 0B. So we are knowing the coordinate of the three vertices of the triangles. So the area of OAB is equal to area of the trapezium OLPB plus area of the triangle PLA, that is 1 by 2 A into B. 1 by 2 A into B, just a simple formula, that is base into height divided by 2, and area of the trapezium will be equal to the sum of the parallel side divided by 2 into height. So you see 1 by 2 into y plus b into x plus the area of the triangle PLA, that is 1 by 2 y into a minus x. Here LA is a minus x. So 1 by 2 and 1 by 2 will be cancelled from all the three places, because one is from the left hand side and others are on the right hand side. So you will get AB is equal to yx plus bx plus ya minus yx. So yx and yx will be cancelled because one is positive and other is negative. So AB is equal to bx plus ya. Now while you divide both sides by AB, you will get x by a plus y by b is equal to 1. This will be the required equation of the line AB, which cuts the intercept on x-axis A and y-axis B. Now the second method, by similarity of the triangle OAB and PLA. So B upon A, you see the B upon A will be equal to y upon a minus x. You see this is a minus x from LA. You see I have written here LA is equal to a minus x. Now just by cross multiply, you will get AB minus BX is equal to AY, that will be equal to x upon A plus y upon B is equal to 1, the required equation.